All right, continuing our conversations about measures of variation. Today we're talking about the mean absolute deviation, which is the last measure of variation we're going to talk about. We do it separate because it kind of takes a long time on its own. So the mean absolute deviation, or abbreviated the MAD, because it's going to drive you mad. If you make one little mistake, your whole entire answer is off. So make sure you're being really careful when calculating this. What it is the average distance. Each data value is away from the mean. So we're trying to figure out how spread out it is. Are the numbers really close to each other? That would mean you have a small mean absolute deviation, or are they really far away from each other? That means you'd have a large mean absolute deviation. So first thing we need to do is find the mean of the data set. What I'm going to ask you to do is to round to the nearest tens place for this, because that's going to make it easier when you're moving on to the MAD, and that's how my answers are going to be calculated. So let's look at this first example. I'm going to find the mean, so let's add these up. 58 plus 88 plus 40 plus 60 plus 72 plus 66 plus 80 plus 48. So really you can use any calculator here, but it's going to be nice if you have a scientific or higher calculator so you can see what you're plugging in, because guess what? If you get the mean wrong, every single thing that you do after this is going to be wrong, and you're going to be really mad at yourself. So we found the sum. There's 1, 2, 3, 4, 5, 6, 7, 8 values, so we're going to divide by 8, and we get a mean of 64. So the mean value is 64. Now the second step, technically you don't have to do this, but when we're finding this anyways, we're already gonna have it in order from least to greatest, because we're gonna be finding the other measures of variation. I like to have it in order too because it makes it easier for me to do the math in my head. So I'm gonna go ahead and list this in order. We've got 40, 48, 58, 60, 66, 72, 80, and 88. Just make sure 1, 2, 3, 4, 5, 6, 7, 8. Perfect. All right, next step is we are going to calculate how far these are away from the mean. So I'm just going to kind of draw little arrows down from each. And you can use a calculator if you need to, or do it in your head. 64 minus 40 is 24. 64 minus 48 is 16. 64 minus 58 is 6. 60 is 4 away. And now we're going in the opposite direction. We're still going to do it as positive. So 64 is 2 away from 66. It is 8 away from 72. It is 16 away from 80. And it is 24 away from 88. So we found the mean. We found how far each value is away from this mean. Now what we're going to do is we're going to find the average, or the mean, of these distances. So basically, I'm going to add all of these up, the distances that we found. So 24 plus 16 plus 6 plus 4 plus 2 plus 8 plus 16 plus 24 equals 100. And to find the average, we're going to divide by, there's 8 values. So divided by 8 equals 12.5. So overall, the actual process of it isn't that bad. It's just being careful with your numbers and what you're plugging in. This was relatively easy because we were given whole numbers as our original values, and our mean was a whole number. You got to be really careful when you've got decimals and you're plugging that in. So this means that on average, our values are 12 away from the mean, which means they're kind of more spread out, right? They've got a large range there. All right, number 2. First thing, I'm going to find the mean. 0 plus 15 plus 8 plus 11 plus 9 plus 7 plus 10. We get 60. Divided by, there are 1, 2, 3, 4, 5, 6, 7 values. So again, I said round to the nearest tenth. It's going to make it easier for finding the MAD, and that's how I'm going to calculate. So this would round to 8.6. for our mean. Then I'm going to put these in order. 0, 7, 8, 9, 10, 11, 15. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now we're going to find the distance, that each number is away from the mean. So I'm going to draw my arrows. Now you got to be a little bit more careful with your subtracting. 8.6 minus 0 is 8.6, minus 7 is 1.6, minus 8 is 0.6. Be careful in the opposite direction. People want to keep writing 0.6, 0.6, 0.6. That's only for those that are smaller. The higher values, 9 minus 8.6 is 0.4. If you can't do it in your head, do it on a calculator. Wow, I wrote 0 there, but that was meant to be a 10. 10 minus 8.6 is 1.4. 11 is going to be 2.4, and 15 is going to be 6.4. So I like doing it in order too, because it makes it easier for me. I just know, oh, that's 1 more, so add 1. Plus 1 is 2. Plus 4 more would be 6. Okay, now we're going to find the mean of these distances. So again, we've got decimals. Be careful when you're plugging it in. If you miss the decimal value, it's going to mix up the whole thing. 8.6 plus 1.6 plus 0.6 plus 0.4 plus 1.4 plus 2.4 plus 6.4 gives me a total of 21 4/10 divided by 7 values. Gives me about 3.057. If I'm to round that to the nearest tenth, that's about 3 1/10. All right. Practice this again. Here are the travel times of 12 randomly chosen New Yorkers. So first thing we're going to do is we're going to find the mean. 43 plus 20 plus 30 plus 5 plus 60 plus 15 plus 45 plus 30 plus 40 plus 57 plus 20 plus 10 equals 375 divided by, it says 12, let's just make sure, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which I'm rounding to the nearest tenth. Even though it's not a terrible decimal, I still want to round to the nearest tenth. This is 31.3. Now I'm going to put them in order just to help me out. I've got 5, 10, 15, 20 and 20, 30 and 30, 40, 43, 45, 57, and 60. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's go ahead and find those distances from the mean. I'm going to draw my arrows. Okay. And then I'm going to subtract. 31.3 minus 5 is 26.3, which means this is going to be 21.3. This is going to be 16.3. This is going to be 11.3. 11, oopsies, not 5, 11.3. This is 1.3, 1.3. 40 is going to be 8.7, 11.7, 13.7. This is going to be 25.7 and 28.7. So again, you can use the calculator the whole time or do it in your head. Just be careful that you didn't make any mistakes. Okay, now we're going to find the mean of this. So we're going to add all these values together. Be careful when plugging it in. So 26.3 plus 21.3 plus 16.3 plus 11.3 plus 11.3 and 1.3, another 1.3, 8.7, 11.7, 13.7, 25.7, 28.7. So we get 177 and 6/10 divided by 12 values. We get 14, we get 14 and 8/10. So since it's a bigger mat, it means it's more spread out, which makes sense. You got someone that only has to drive 5 minutes for work, another one that has to go a whole hour. So that data is a little bit more spread out. Not going to worry about the you try, just want you to move on to the homework.